All right, we're going to be talking about interpreting box plots. And so yesterday we learned about creating them. And today I'm going to give you a box plot and talk about how, again, we talked about this yesterday, but how it has 4 sections. So from dot to dot is each section. So that's 1 section, 2 sections, 3 sections, 4 sections. So since there's 4 sections from here to here, dot to dot, that is going to be 1/4 of the numbers, or 25% of the numbers will fall between 56 and 75. So 1/4 or 25% of the numbers will fall in between there. So between this dot and this dot is going to be 25% of the numbers. Between this dot and this dot is going to be 25% of the numbers, or 1/4. And between that dot and that dot, 25% of the numbers will fall in between those two numbers, in between 91 and 99. So I know that when we talk about fourths, we talk about each section being equal. So I know this section looks larger than this section, but it's not actually. All right, if we have 12 quiz scores, okay, 12 divided by 4 sections mean that there's 3 numbers in this section, there's 3 numbers in between these 2 numbers, there's 3 numbers in this section, and 3 numbers in this section. This section is just more spread out than the other sections. That's why it looks bigger. It doesn't mean that there's more numbers in it. It just means that it's more spread out on the number line. So if the box plot shows 12 quiz scores of a student this year, all right, this only shows 1, 2, 3, 4, 5 pieces of information. So you do not know what those 12 quiz scores are because it does not give us a list. Okay, so that's something that we do not know, is that we do not know the list. We know there's 12 numbers, but we don't know the numbers in the list. So we can't find the mean. Okay? Remember, the mean is the average. That's when we add those numbers together and divide by how many numbers we added together. If we don't know the numbers, we can't add them together. Therefore, we can't find the mean. So on the STAR test, it might give you a box plot and ask these types of questions, all right, or ask you if they're true or false. So when we're looking at this, I go ahead and I gave you the numbers up here, okay, since it's kind of hard to see what the numbers are. And so we're going to answer these questions. We did this one yesterday. What is the interquartile range? Now remember, range means biggest number minus smallest number, but since we're looking at the quartiles and subtracting those, we're going to look how big the box is. So 91 minus 75. That's how we're going to find the interquartile range, and that's going to be 16. All right, what percent of the scores were 56 to 75? So 56 to 75, that's 1 section, so that's 25% of the scores fell in that section. What percent of the scores were 75 to 91? So 75 to 91, see how that's 2 sections. So 25%, 25% plus 25% is 50%, all right, which is also half. They might say 50%, they might say half. It just depends on the vocab. C, what percent? Oh, we did that one. D, the middle 50%. Okay, so the middle 50% means that there's 2 boxes. So from here to here, that's 25% and 25%. This is what is called the middle 50%. Okay, here's the first 50%, the first 2 sections. Here's the middle 50%, the middle 2 sections. And from here to here, that's the second 50%, the second 2 sections. So the middle 50% of the scores, middle 50%, was 75 to 91. So I'm going to scoot this up a little bit. E, true or false? Half, okay, so half, remember, that's 50%. 2 sections. Half the scores were 82 to 99. So 82 to 99, is that 2 sections? Yes, that's 2 sections. So this is going to be true. F, True or false? 75%. Now think about what 75% is compared to 25%. That's 75% is 3 groups of 25%. 3/4 is 75%. So that's going to be 3/4 or 3 out of 4 sections up there. So 56 to 82, that's only 2 sections. That's not 3 sections. So that's 50%, not 75%. So this is going to be false. So let's go ahead and correct this. So 56 to 82 is 50% because it's 2 sections. We want 3 sections to be 75%. So 1, 2, 3 sections. So it would be 56 to 91. That would make that true. G, true or false? The range of the data is 43. So remember, range is the biggest numbers minus the smallest number, whisker to whisker. So 99 minus 56 is going to be, yes, 43. So that's going to be true. Name the median from the box plot. Now median, remember, when you're looking at a box plot, is always the middle dot, okay, in the box. So that's going to be 82. So true or false? Half, okay, so 50%, remember 2 sections. Half the scores were 82 or less. So 82 or less, that's 2 sections. So yes, that is half. So that's going to be true. All right, let's go to the back. So when you have box plots, again, they don't give you a list of numbers. So you cannot find the mean. You don't know how many numbers in the list. So it says the box plot summarizes the attendance. So that means how many people attended the spring band concert and the fall band concert. Each band concert was performed for 6 evenings. So that means that the spring band concert has 6 numbers and the fall band concert has 6 numbers, but we don't know what those numbers are. So that still doesn't help us much as far as knowing how to find the mean, because we don't know the list of the actual 6 numbers in each concert. So it says which statement best describes, okay, that means which one is true. Which statement best describes the data represented by the box plots? So A, the range in attendance, so remember range is high minus low, for the fall band concert is 85. So I'm looking at the fall band concert. That's going to be 225. That's going to be 130. So I'm going to say largest number minus the smallest number, and that's going to be 95. So no, that's not right. So we're going to put false over here. The interquartile range, remember, that's subtracting the quartiles, for the spring band concert is 45. So go to spring band concert. This dot right there, that's going to be 195. And this dot right there, that's going to be 135. So 195 minus 135 is going to be 60, not 45. So that's false as well. We're looking for the true one. For half, remember half means 50%, 2 sections. For half of the evenings at the fall band concert, the attendance was less than 60. Well, this doesn't even go to 60, so we know that that's false. If we made that true, we would say, okay, well, we need 2 sections, so it's going to be less than 165. And again, if I'm going too fast, you can pause it at any time. D, the range in attendance for the spring band concert is 80. So range, high minus low, for the spring band concert. So we have 200 minus 120 is going to be 80. Yes. So this is our true statement. Okay, let's look at this next one. Number 2, students recorded the amount of water in fluid ounces each of them drank in 1 day. The box plot shows the summary of the results. It didn't tell us how many students. It didn't tell us the list. Okay, and we don't know what the list is. Now these are hard to read, but if we use these numbers, we're going to get an idea of how to label some of them. So 78, I'm going to think that's 78. Then we have 114, that's going to be 114. I see 30, it's going to be 30. Okay. So which statement best describes, so again, which one's true? Which statement best describes the data represented in the box plot? Half, okay, so half, remember, is 50%, 2 sections. Half of the students drank from 78 to 114. So 78 to 114, that's 2 sections. So 25% plus 25% is the 50%. That's going to be true. The greatest number, okay, so the greatest number of students means that we're comparing it to something else. So the greatest number of students, that means more than 50%. Okay, strength from 30 to 114. 30 to 114, well, that's all of it. So if I give you the whole thing, we're not really comparing it to another section or to another half or anything like that. So that's going to be false. The data represents 78 student responses. That means there's 78 students that told us how much water they drank. And we don't know how many students. So that's going to be false. That information is not known. We don't know. And then D, the mean. Again, can we find the mean if we don't have a list of numbers? No. Okay, so we have no list of numbers. So that's going to be impossible.